Hello everyone, myself Dr. D. Sree Lakshmi, Assistant Professor in the Department of AML at Institute of Aeronautical Engineering. In this session, I am going to discuss about iteration method, and this is used to find out the roots of the given function. Here is a problem where we need to find out the root of the given equation using iterative method. As we know, the formula for iteration method is xn plus 1 is equal to xn whole power, the data whichever given we will consider at a fixed point. At a fixed point. It means here we need to satisfy a condition that g dash of x for the given function x should be less than or equal to 1. To satisfy this particular condition, we need to rearrange the given function in a proper way. So that is, the given function is x cube minus 2x minus 5 is equal to 0. This is the given function. Now here we need to fetch initially x value. So here g dash of x should be less than or equal to 1. X cube is equal to 2x plus 5 and x is equal to 2x plus 5 whole power 1 by 3. And here this is the function which we rearranged from the given equation. Instead of this, if the another method x cube is equal to 2x plus 5 and here x cube minus 5 is equal to 2x, x cube minus 5 by 2 is equal to x. If we select like this, if we rearrange the given equation in this format, then this condition will not be satisfied. This condition will not be satisfied. To satisfy this particular condition, we need to consider always the higher order term initially, and then from that higher order term, we need to define the equation. So, we should not consider this way, we need to consider in this way. As here in this equation, x cube is the highest one, x cube is equal to 2x plus 5, and then from this equation, x is equal to 2x plus 5 whole power 1 by 3. This one will satisfy the condition. It will be less than or equal to 1. So now we will find the real root for the given function. So here the given function f of x is equal to x cube minus 2x minus 5. And now we rearrange this in terms of x is equal to 2x plus 5 whole power 1 by 3. Now initial guesses need to be considered because the root always lies between a negative value and a positive value. So that initially we will consider x is equal to 0, so that f of 0 is 0 minus 2 into 0 minus 5, that is minus 5. Next, f of 1. So 1 minus 2 into 1 minus 5, where even this is also a negative value. Next, f of 2. So 2 cube, 8 minus 2 into 2 minus 5. So 8 minus 9 minus 1. And now f of 3. For this 3 cube 27 minus 2 into 3, 6 minus 5. So how much? 27 minus 11. So this is 16. So here we got a positive value and here we got a negative value. So we can consider the root lies between 2 and 3. The root lies between 2 and 3. So here we are considering x0 is equal to 2 and x1 is equal to 3. Since iterative method is at single point, iteration at single point, we will consider the average of these two values. So x0 plus x1 by 2, which is 2 plus 3 by 2, so which is 2.5. So we are considering the initial guess x0 is equal to 2.5. Initial guess x0 is equal to 2.5. Now, in the formula we will substitute and then we will find the root value, approximate root value. Since they didn't give an n number of decimals, we will consider up to 2 decimals or up to 4 decimals. So now, I am having xn plus 1 is equal to xn 2 into xn plus 5 whole power 1 by 3. Now for first time n is equal to 0, x1 is equal to 2 into x0 plus 5 whole power 1 by 3. As per our assumption, x0 we considered 2.5. So now 2 into 2.5 plus 5 whole power 1 by 3. And this is what? This is x1. And the value of this x1 is 2.1544. And now n is equal to 1, where x2 is equal to 2 into x1 plus 5 whole power 1 by 3. That means 2 into 2.1544 plus 5 whole power 1 by 3. So here what we taken? x1 is how much? 2.1544. Since the root value whichever we are finding out is at a fixed point. So here the x1 is how much? 2.1544. That value we will use for finding the root x2. So this value is equal to 2.1036. After simplifying this, you will get 2.1036. Next, n is equal to 2. So x3 is equal to 2 into x2 plus 5 whole power 1 by 3, which is equals to 2 into, now x2 is how much? 2.1036, that we will substitute 2.1036 plus 5 whole power 1 by 3. And this value is approximately equal to 2.0959. Next iteration. This should be continued till the root values for iteration, at least for 2 iterations, should be same. Since we consider up to 4 decimals, the iteration values of 2 iteration values should be same. So now x2 value is 2.1036 and x3 value is 2.0959, where they are not same. So we are moving on to the next iteration. N is equal to 3. That means x4 is equal to 2 into x3 plus 5 whole power 1 by 3. So which is equal to 2 into 2.0959 plus 5 whole power 1 by 3. This is approximately equal to 2.0947. If we are considering up to 2 decimals, we can stop here. We can conclude that the root of the given function is 2.09 if we are considering for 2 decimals. But here we are considering up to 4 decimals, let us see how many iterations it requires. So for the next iteration, n is equal to 4, x5 is approximately equals to 2 into x4 plus 5 whole power 1 by 3. So how much this value is? 2 into x4 value is 2.0947 plus 5 whole power 1 by 3. And this approximate value is 2.0945. And now n is equal to 5. x6 is approximately equal to 2 into x5 plus 5 whole power 1 by 3 approximately equals to 2 into 2.0945 plus 5 whole power 1 by 3, which is approximately equal to 2.0945. So here if you observe, for iteration n is equal to 5 and n is equal to 4, that means x5 and x6 both values are approximately equal to 2.0945. So now we can conclude that the root of the given function is 2.0945 approximately. Since we taken up to 4 decimals, we went up to 6 iterations. If you are closing to 2 decimals, then you can close at 4th iteration, where the value is 2.09. The root value is 2.09. Since we consider 4 decimals, we went up to 6 iterations and the value is 2.0945. So this is the approximate root value for the given function. Now we will do one more problem. Using the iteration method, find a real root of the equation f of x is equal to x into e power x minus 1. So same condition we need to satisfy. G dash of x should be less than or equal to 1. So to satisfy this condition, we are considering the given equation as f of x is equal to x e power x minus 1. This is the given function. Now we are considering x e power x is equal to 1 and x is equal to 1 by e power x, or you can also consider x is equal to e power minus x. So where xn plus 1 is equal to e power minus xn. As same, we need to find out the initial values. In the given function, f of 0, that is x is equal to 0, substituting in the given function, f of 0 is equal to 0 into e power 0 minus 1, which is equal to minus 1. And similarly, x is equal to 1, f of 1 is equal to 1 into e power 1 minus 1, where it is a positive value. Might be some 1 point something, and here it is a positive value, and here it is a negative value. So always a root lies between a negative value and a positive value. We can consider the initial guesses as x0 is equal to 0 and x1 is equal to 1. Since we need to consider only one root initially, here we will take average of these two values. Because the root lies between 0 and 1, we can take average of these two values. So x0 plus x1 by 2 is equal to 0 plus 1 by 2, where we are considering the root value x0 is equal to 0.5. This is initial guess. Now, as given in the problem, the function xn plus 1 is equal to e power minus xn. So now we will find out, for this we will find out the root value. So let or consider n is equal to 0. So x1 is equal to e power minus x0. So where it is equal to e power minus 0.5. So what is the value of that? E power minus 0.5 is 0.6065. Now, n is equal to 1, x2 is equal to e power minus x1. So which is e power minus x1 is how much? 0.6065. So that is equal to 0.545. So in this problem, I am going to consider only up to 2 decimals, not up to 4 decimals. So here I am going to consider up to 2 decimals only. So when n is equal to 2, that is for third iteration, x3 is equal to e power minus x2, which is equal to e power minus 0.545. So this is equal to 0.579. And now when n is equal to 3, x4 is equal to e power minus x3, which is equal to e power minus 0.579, which is equal to 0.560. And now when n is equal to 4, x5 is equal to e power minus x4, that is e power minus x4 is 0.560, and this is approximately equal to 0.57. Similarly, for n is equal to 5, x6 is equal to e power minus x5, which is equal to e power minus 0.57, which is approximately equal to 0.56. Here I am going to consider only 2 decimals. Now n is equal to 6, x7 is equal to e power minus x6, which is equal to e power minus 0.56, which is approximately equal to 0.56. Up to 2 decimals. So here, since we consider up to 2 decimals, we went with 7 iterations, and here the 7th iteration and previous, that is 6th iteration, we got the same values 0.56 and 0.56 up to 2 decimals. So here we can conclude that the root value for the given function x into e power x minus 1 is 0.56. This is up to 2 decimals. If we consider 4 decimals, then we need to approach more number of iterations. So in this way, we will find out the root of the given function using iterative method. And the content is taken from SS Sastry. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.